We're going to cover the exercise on slides 44 to 46 in my lecture. That is exponential smoothing. The data set that we are going to use is the Occam's law data set. So we need to open the data file first. Just go to my Word document, the PDF document, and copy and paste the command, submit over here, and you will have the data open. Before we proceed to the next step, let's use the data editor to have a look at the data set first. So I want to draw attention to the fact that in total we have 98 observations, and the last quarter is the third quarter of 2009. Later, we would like to make a forecasting for the next quarter. That's the last quarter of 2009. Okay, now let's go back to Stata window. Our next step is to create a new observation at the end of this data file. So it's a space for us to make a prediction. So that's the command line, ts append observations to a time series data. And we add only one, just one observation. What's the effect of this command? So let's go to the data window and have a look. So the data window is open right here. And you may notice that now we have 99 observations. And the last one, we have a data index there, but we have missing value for both G and U, the dependent and independent variables. Because we don't have the value, but the time we can create automatically. And this is the time period we would like to make forecasting. We'll come back to that later. The nice thing of putting this observation in is when we create some new variables, prediction based on exponential smoothing model, they will be put into those columns and they will automatically calculate what is the value for this new observation or this quarter. Okay, now let's go back to Stata. In Stata, the command to estimate a exponential smoothing model by using a parameter of 0.8 is here. I copy and paste the command line in this window. So tsmooth is the command. We specify the model we would like to use is exponential smoothing. The variable we would like to use is G. And the prediction, the new variable that was created based on this exponential smoothing procedure is called SM2. Then PARMs, this parameter, we put the parameter we would like to use in this set of braces. If you submit this command line to Stata, two things will happen. First, it shows to us, okay, you tell me to use 0.8 as the smoothing parameter. I used it. The sum square for residual is calculated as 35.45. That's just the difference between the predicted and the observed values. And the root mean square error is calculated as well. Okay, so that is the statistics. And right-hand side in the window, you may notice that we have a new variable added to the list. What is it? So if you click Data Editor, it will open the data window and you will see, just like you can see from my window, a new variable is created. It's called SM2. That's the predicted value of G based on its exponential smoothing model. And the last observation is calculated as 0.5612844. That is based on an exponential smoothing model with the 0.8 as the smoothing parameter. So now we can see the benefit of adding this observation into the data set before we run the model. Because of those missing value, this observation didn't enter the estimation. However, because it's put in already, the software will calculate the predicted value of this observation. You may wonder how exactly was that value calculated? Okay, if you are interested, you can use the formula from my PowerPoint slide and use these two command lines to calculate and display the value manually. So that's the formula. that we used in a PowerPoint slide. So that basically is the weighted average of the observed value of G and the estimated value of G in quarter 98. And we're predicting the value in quarter 99. That's the last quarter. So if we press enter, that shows you exactly the same value as you saw in the data file. So you can open data editor, have a look at the last observation of SM2. That's the predicted value. This is how the software did the calculation. Okay, so this is to force the smoothing parameter to be 0.8. Actually, the software can determine the optimal parameter for us. All you need to do just to remove that parameter part. Don't tell the software what to do. Let it decide what is the optimal smoothing parameter. Of course, this time we want to store the predicted value in a different variable. Do not override SM2. So SM3 is the one using the optimal smoothing parameter alpha. Then what is it? Okay, the software calculated, it shows the optimal exponential coefficient of alpha actually is 0.38. That's the second smoothing parameter that I use in my PowerPoint. And you may notice in this window, we have SM3 calculated as well. So you can open the data window and have a look at the new variable. So we have SM3. So this one uses smoothing parameter of 0.38. SM2 uses 0.8 as the smoothing parameter. You can tell by changing the smoothing parameter, the difference is quite large. Okay, now if you go back to Stata, you can use this command line to generate the line chart that we had before on my PowerPoint slide. So this one will show to us this diagram. So that's the comparison between the observed value and the predicted value. So G and the G hat. And because we use alpha equals 0.8, you may notice that those two lines are very similar to each other. It looks like G hat just one step behind G. What's going to happen when we change the smoothing parameter is the pattern of the predicted line will change. So let's go back. If we change the comparison to be between SM3 and G, that will give us this diagram. So in comparison, this time the blue line, the solid line is smoother. It's because we are now using a smaller smoothing parameter. So recent observations are carrying lighter or smaller weight in comparison. That's the prediction, but this is the best or optimal smoothing parameter identified by the software. We usually go with it.